Jack inherited a perpetuity due with annual payments of 15,000. He immediately exchanged perpetuity due for a 25-year annuity due having same present value. The annuity due has annual payments of X. All present values are based on annual effective rate of 10% for the first 10 years and 8% thereafter. Calculate X. So the interest rate is different for the first 10 years. Therefore, we need to break up the present value of the perpetuity into present value of the first 10 payments plus the present value of payments 11 onwards. So the first 10 payments form an annuity due because the payments start right now. It was perpetuity due. And so if you just consider the first so many payments, the first so many payments of a perpetuity due is an annuity due. And the reason why we broke it up into first 10 payments and then the remaining ones is that the interest rate is different for the first 10 years. So the first 10 years, the interest rate was 10%, 0.1. So present value of the first 10 payments, therefore, by the perpetuity due formula would be the payment, which is 15,000 times 1 minus 1 plus I to the negative n. So 1 plus 0.1 power negative 10 over I, which is 0.1 times 1 plus I. And this gives us 101,385. Now, the 11th payment occurs at time 10. So remember, this was perpetuity due. The first payment occurs at time 0. And the second payment happens at time 1, third payment at time 2. So every payment happens at one time less. So 11th payment happens at time 10. So the present value of 11 payments onwards at time 10 is what we get when we use the typical perpetuity due formula, which is X times 1 plus I over I. And remember now the interest rate has changed to 8% after time 10. So when you do the X times 1 plus I over I, you get 15,000, 1 plus 0.08 over 0.08, that's 202,500. But that's the present value at time 10. And we need to push it back to the present value at time 0. And the thing to note is that this value is setting at time 10, this 202,500. And when you bring it to from 10 to 0, you are again going through the interest rate that was in the first 10 years, because now when you go from 10 to 0, you are in the first 10 years. And so it will be pushed back through the interest rate of 10%. So we multiply it with 1.10 power negative 10. So this 0.1 happens after we do 1 plus 0.10. And this negative 10 is because we are pushing it back 10 periods. So we get 78,073. And now we have both the bits of this right-hand side. And therefore, the present value for perpetuity is the present value of the first 10 payments, which was 101,385, plus the present value of the remaining payments, which was 78,073. So you get 179,458. That's the present value of the perpetuity. So now we are told that this perpetuity is immediately exchanged for a 25-year annuity due. So the annuity due will also have a present value of 179,458. And again, the interest rates are varying. So even this annuity due will have to be broken down. It's a 25-year. And so we'll have to break it up into the first 10 payments and the remaining payments. So the present value of the first, and the total present value is 179,458 equals present value of the first 10 payments is X times 1 minus 1 plus 0.1 over 0.1, because it's 10% for the first 10 payments, and then power negative n, so negative 10 times 1 plus I, so that's a perpetuity due formula. And then the remaining one is also a perpetuity due formula. Now we have 15 payments. the payments 11 through 25, but now for them, the interest rate is 0.08. So again, the payment 11 happens at time 10. So the present value we get is at time 10 when we use the formula. So this whole thing is sitting at time 10. And then to push it back to time 0, we again have the interest rate, which was for the first 10 years, because now we are moving between 10 and 0, which is the first 10 years. And so, no, not this one, this whole thing. Yeah. So my mistake. I said that the present value was just this half, but the present value at time 10 is all this shaded portion, because the 1 plus 0.08 is also a part of the due formula, annuity due formula. And then this is the factor which pushes it back from time 10 to time 0. Again, once again, this one is sitting at time 10. That's the perpetuity due formula. And then this one pushes it from time 10 to time 0. So when you simplify the right hand side, so we have x times something and then plus x times something. And so where you evaluate all this, add them up, and you get 10.323x. And then when we divide by 10.323, you get 17,384. That's choice B.